For this problem, we're going to determine if a function is a one-to-one function. Here we have two functions. In A, we have the function y equals 4x squared plus 3, and in B, we have y equals the square root of x plus 3, and then minus 5. We're going to determine whether these functions are one-to-one. If we begin with A and consider this function, we see that this is a quadratic. We know that the graph of a quadratic is a parabola, and the parabola could open up or down. In this particular case, our leading coefficient is positive, so we know that the graph of this function is going to be a parabola that opens up. So the graph will look something like this. If we want to use our horizontal line test with the graph, we can see that the horizontal line will pass the graph in more than one spot. So this function is not one-to-one. We could also see by using some values, we might try x is equal to -1, and evaluate the function and see what we get. If we put in -1, we get 4 times -1 squared plus 3. -1 squared is 1 times 4, so we get 4 plus 3, which is 7. If we let x equal +1, we get y is equal to 4 times 1 squared plus 3. 1 squared is 1 times 4, so we get 4 plus 3 is also equal to 7. So we see that two different x values give us the same y value, and the function is not one-to-one. For our second function, we've got a square root function. Keep in mind our techniques for shifting, reflecting, and stretching that we used when we did transformations. The square root function, if we graphed it, would look something like this. If we were using the horizontal line test, we could see that there's no place along this graph where we could put a horizontal line that would hit the graph in more than one spot. So the function is one-to-one. You could plug in different values, and you would see that for each x value that you put in, you're only going to get one value out of the square root. You get the principal square root. And so again, we'd see it's one-to-one.